Alright, so welcome to your turn, page 171 solution. So if you're watching this video, then you've already completed example 2, analyzing a quadratic function. So you've worked through the example with your graphing calculator, a pencil, and your paper. And you were confident that you understood what you were doing, so then you attempted your turn on your own. And now you're watching the video to check your solutions. Or perhaps you did example 2 and had some difficulties, so you ended up contacting your teacher, asking some questions, then you tried your turn on your own, and now you are checking your solutions. But either way, you already have completed the your turn, and you're just checking your solutions. You're not getting them. There's a difference. So a diver jumps from a 3-meter springboard with an initial vertical velocity of 6.8 meters per second. Her height, h in meters above the water, t seconds after leaving the diving board, can be modeled by the function h of t equals negative 4.9 t squared plus 6.8 t plus 3. So just by looking at this equation, we can tell that it's in standard form, and we see that our a value, our b value, and our c value. And we can note that in front of our a value there is a negative sign. And anytime we have a binomial, we know that we have a parabola. And anytime that our a value is negative, we know that we have a parabola that's going to be opening downward. And every time we have a downward opening parabola, we have a maximum value. Alright, so there's just a couple of things that we've already noticed, hopefully right off the top. But if we're not noticing them yet, some more practice we will. So A says graph the function. So I have provided just a quick sketch of the graph. So the decimals in the equation can make it a little tricky. You were still more than welcome to use a table of values. So you could have done a table of values and calculated out your points for your parabola, or you could have used Excel on your computer, or you could have grabbed your graphing calculator or used the graphing calculator software provided online to graph the equation. So once it's graphed, it's always a good idea just in your notes to make a quick sketch of the graph. It doesn't have to be to scale, it doesn't have to be perfect, but it should include the vital points. So in this instance, or in most instances, you'll have your intercepts. So in this case we have a y-intercept and an x-intercept, as well as our vertex. Alright? So, and then of course everything is labeled as is good graphing technique. So we have a graph. B says, what does the y-intercept represent? So if we look at our y-intercept, and our y-intercept happens at 0, 3, and of course it's going to be 0 because our y-intercept is always when our x value is equivalent to 0, or in this case we're using t and h of t, which is the same as using x and y. So that is the height of the diving board, because the diving board is 3 meters above the surface of the water, and the surface of the water is at 0. Okay, so B, okay, what does the y-intercept represent? The y-intercept equals height of the diving board. Alright, C says, what maximum height does the diver reach, and when does she reach the height? Well, we already know that we have a parabola, it's downward facing. We know that our vertex is going to be our maximum point. So if you think about it, when the diver leaves the springboard and going up, she's increasing in height. She's going to reach the maximum height possible, and then it's going to be decreasing. Right? So for C, we know that our vertex is going to be our maximum. So the maximum height reached equals 5.36 meters. And when does she reach that height? She reaches that height at at 0.69 seconds. Okay? C said, oh, sorry, that was C. D says, how long does it take before the diver hits the water? So when she connects with the water, and we know that our water is at 0, so we're looking at our t-intercept, or our x-intercept, we know that that's going to occur at 1.74 seconds. Okay, so she hits the water. At 1.74 seconds. Okay. E says, what domain and range are appropriate in this situation? Okay, so a couple things you need to ask yourself is, what are the domain and the range? Well, we know that the domain are all possible values of our x, or in this case, our t. So, can we have a negative time? So no, we can't have a negative time. And because we're specifically looking at this situation, we know that our x values are going to be all values from here to here. Right? So we can write that out specifically by saying, put E here, I'll do E in purple. So we know that it's our domain, and we know that there are specific ways that we write domain. There is a notation. So domain always starts with a curly bracket, and our symbol in this case is a T. If it was X, we'd put X. If it was Z, we'd put Z. Okay, we put our line there. We know that it's going to be, has to be greater than 0, but less than 1.74. So we write that by saying 0 less than or equal to our t value, which is less than or equal to 1.74. Okay, and t is any real number. Remember that our little e symbol is an element of, and we can say that as any real number, an R for real numbers. Okay, and then our range, okay, is all our possible values for h of t, so our y values. Okay, so in this case we look at the whole range of the graph, and we know that because she connects with the water at 0, and the maximum height that she reached at our vertex was 5.36. We know that for the range, which is our h value, okay, is going to be greater than 0, so greater than or equal to 0, but less than or equal to 5.36. And again, our h value can be any real number. And that looks like a t, but it's, oops. It's not actually a t. I'll just make that a little better. Okay. That's an R, but it doesn't look like an R. Just clean it up a little bit. Right? So that's our domain and our range. And then last but not least, it says, What is the height of the diver? 0.6 seconds after leaving the springboard. Alright, so if she's leaving, let's use the highlighter here. Now let's just go with a nice light color. Okay, so she's leaving the springboard when she hits 0.6 seconds. So what is our H value? So we can do this a couple ways. You could use the trace function on your calculator, but you're going to find out very quickly that 0.6 could be very hard to pinpoint. So let's solve it algebraically. So I'm just going to erase some of our previous work, just so that we have some room here to do it. Okay, so then so our H of 0.6 equals negative 4.9, 0.6 squared plus, and although we shouldn't do this on your paper, make sure you're doing it in a line. I'm just going to come down to the next line just because I am running out of room. So 6.8 times 0.6 seconds plus 3. So 0.6 squared times negative 4.9 added to 6.8 times 0.6 plus 3 equals, you are correct, all of you should have 5.32. Okay, meters. So are we done? Nope. We need to make sure that we write a sentence. The sentences are important. We should always try to include a sentence when we're answering these questions. Complete sentences are best because it not only tells the teacher that you understand what you're doing, but it also helps clarify things for you. It makes connections between the numbers, the graph, the calculations, and then the context of the problem as well. So the diver has a height of 5.32 meters, 0.6 seconds after leaving the board. Alright, and that concludes our solution for your turn on page 171. So if you have any questions, please make sure you're contacting your teacher. So thanks for watching.